Great, thank you. So I was saying there's a correspondence between these two flavors of identifiers for entities within a given semantic space. Here I'm using CHEBI, this chemical entities vocabulary from EBI as an example. And within a given vocabulary, typically there is a prefix in URIs. The beginning part is always the same. And then at the end, there's a local unique identifier, which says actually which entity within that semantic space are you talking about? So in this example, we have the same entity written both as a URI and as a query. This corresponds to a chemical called alsterpolone, which is inside CHEBI. One of the problems that the bioregistry helps us solve is building these correspondences between how these URIs look and how these compact URIs look, or queries. I'm going to say queries from now on. The problem is there's actually a lot of heterogeneity in how people write down compact URIs. What is the prefix that people use for a given ontology or database or semantic space? This example shows that if you want to refer to a compound from the PubChem compound semantic space, depending on which resource you're looking at, they may write queries with many, many different prefixes. Some write PubChem, some write PubChem.compound, some write CID. And this is a big problem for data integration and data standardization, because if you have data from two different sources that label the same entities with different queries, you can't directly integrate them together. There needs to be a standard. Well, the short version is the bioregistry keeps track of all of these and becomes sort of an actionable standard. So we can say, if you want to talk about a PubChem compound, the actionable standard is to use PubChem.compound as your query prefix. Now, the people in the room who are big fans of the semantic web might say, URIs solved that problem. They're completely ambiguous, they're globally unique, they're persistent, and yes, those things are all true, but people also can't agree on what's the right URI for a given entity. So the heterogeneity for what URIs corresponds to the same entity within a given namespace, and here we are back with CHEBI. You can construct many different URIs that correspond to the same entity within the CHEBI ontology. So we have the same problem again from the other side. How do we decide which is the one correct one? And the good news is in CHEBI and for many resources, there is an obvious standard. So the OBO Pearls, this is part of the Open Biomedical Ontologies Foundry. They've created a system that is an authority that names what are the URIs for entities. So in this situation, we would want to use the OBO Pearl as the standard. The bioregistry is also going to help us do that. However, it's not always so easy, and that's why it's worth keeping track of all these things. So, like I mentioned before, the grand challenge of data integration is if different resources are using queries or URIs, and they're using different queries or different URIs that correspond to the same entity, how do we identify what's the correct one to use, and how do we standardize our data onto those so we can easily integrate our things? So before we actually solve that problem, there's a couple big questions to ask. What are all of the prefixes? How do I even know what are the different ones that you might use for a given vocabulary? And what are even all of the resources? So there may be ambiguity between which prefixes are used. So we want to keep track of what are all the prefixes and what are the resources they correspond to, and metadata like the name of the resource and who's responsible for it and how do I download a copy of it. And who keeps track of all of these queries and URIs and all of the metadata associated with them? It turns out there were already some resources before the bioregistry that were keeping track of this. However, they were limited in scope, had project-specific needs. Some of them weren't under heavy maintenance. And so that's another thing to keep track of. And to what extent are the prefixes already standardized? I already let the cat out of the bag. There's a lot of unstandardization in queries and prefixes. So with all of these questions in mind, we built the bioregistry. I'm going to just skip a couple slides forward. And so the goal of the bioregistry, like I mentioned, is to keep track of what are all the prefixes used in queries and URIs and all of the metadata associated with those records. The bioregistry goes a little bit further than that, and it also takes all of the existing registries that have similar kinds of metadata, and it incorporates all of them, both to reduce curation burden and also to establish consensus. And in addition, it provides tools like a resolver, which lets you take a given query and turn it into a URI and then resolve to that website. Because for the most part, the URIs all correspond to websites that have information about the entities that you want to reference. It does all this while being open, both using an open code model on GitHub, having the data also be version controlled and licensed permissively, and building on top of open infrastructure to run all of the data validation, data integration, and make deployments on a nightly basis or weekly basis. And this openness allows the community to interact with Bioregistry and to make suggestions, to ask for new features, and ultimately to make it easier to operationalize the standard that it induces. And to do all of this in a nice way, it also has to have this community orientation first, where the project has contribution guidelines, a code of conduct, governance that allows it to be sustainable. And with respect to some of the other things that, for example, the Global Biodata Coalition is talking about, this allows the project to be a little bit more robust to changes in funding, changes in the availability of personnel, and yeah, so the project can ultimately be sustainable in the future. So what is worth mentioning, there's a couple common misconceptions about what the Bioregistry doesn't do. So I want to just make sure that everybody's aware. The Bioregistry doesn't download all of the resources, all of these ontologies and databases. It does not keep copies of all of the information from them. It's merely a library of metadata about these resources. So for example, I use this specific molecule from the KEBI vocabulary. The Bioregistry can help us standardize the way we reference KEBI, and it can resolve a query to the website in KEBI, but it doesn't actually have the information from the KEBI ontology. There are other resources that do this sort of thing, that keep track of all of the entities within ontologies and databases and control vocabulary. So a couple of those are the ontology lookup servers from the EBI. This is, in my opinion, the gold standard. Some other ontology-based ones like ABRA-OWL, ONTOBE, and BioPortal. And there are other larger resources like Bio2RDF, which are more holistic in the way that they incorporate databases and other information. Okay, and the Bioregistry doesn't solve yet another higher, more abstract problem in data integration, which is what happens when the same entity appears in multiple controlled vocabularies. So what that means is aspirin has a KEBI identifier in the KEBI ontology. Aspirin also appears in pubchem.compound and probably also appears in the drug ontology. The fact that there are many different resources naming the same entity, giving an identifier, the Bioregistry doesn't solve the problem of mapping between those things. I'm interested in this problem myself, and so we can talk about this later. Biomappings, the SESAM standard, and SEMRA are a couple things that help solve this problem in practical data integration, but we can talk about that later if you're interested. Okay, let's double check how we're doing on time. Let's go a little faster. So what's in the Bioregistry? Right now, there are almost 2,000 unique prefixes. Each of those prefixes corresponds to either an ontology, a database, some kind of semantic space that appears in databases or other ontologies as cross-references. And these are a combination of existing registries plus curation of things that we've found in our unique data needs. This goes over the biomedical domain, it goes over the life science domain, into the semantic web, and even a little bit outside into other natural sciences. Over all of those prefixes, there are 524 synonyms. Remember back to the slide about pubchem.compound with this wheel where there are many different prefix synonyms. And so it turns out that there's a lot of synonyms that exist that are necessary to do data standardization. I mentioned that we're also incorporating and aligning with other registries that have similar or overlapping focus to the Bioregistry in terms of keeping track of metadata for resources. So there's 32 external registries that we're using. So these include things like fair sharing, RA3 data, the OBO Foundries registry, the OLS itself. And to map between all of the Bioregistry records and the records within these external registries, we have over 8,000 mappings, including negative mappings, which allows us to disambiguate things that may look like they're the same resource, but they actually aren't. The Bioregistry has been curated in part by many external contributors. So there's, with many databases, a core group of people who do curations, and then other people can come with their specific needs and make small curations when they feel like it. We've talked about this in the past in the ISB conferences as what's called a drive-by curation. And so it makes me very happy that there's many direct contributors that only have made one small typo fix over their career. And I think that that's really valuable, that it's possible. So in terms of what's in the bioregistry, it will never be complete. This is a database that is trying to reflect the state of biomedical research. People are always creating new databases, ontologies, resources. And so as those are created, we'll want to incorporate them. And we'll talk a little bit later about some of the modern tools for keeping the bioregistry up to date. Let's skip forward. So what does this actually look like? There are many resources that appear in some registries, but not all. So this shows that there's one prefix in the bioregistry that appears in 22 different external registries. This is the NCBI taxonomy. So this is a very important resource that everybody has something to say about it in their registries, whether your registry talks about the database itself or the ontology that's induced by it in the OVO Foundry. And there's sort of a long tail of resources that appear only in a couple places. And the point of this graph is to show that the bioregistry and its ability to align external registries is important because none of the individual registries that existed before really covered the whole state of the biomedical landscape and all of the resources in it. And the green bar shows we've got 336 novel prefixes. This number has gone up and down over time because other registries also make their own curations. And so sometimes we've had more novel ones that have then been incorporated into others. So a different look on that is, given that your favorite registry is, let's say, identifiers.org, because you've been working in the systems biology modeling field, if you were just using identifiers.org, you've only got 816 prefixes. And if you use the bioregistry, which incorporates identifiers.org, it substantially extends it with many other prefixes that might be useful within your systems biology modeling. So this is the same for many of the different registries that exist. There's always this significant gain on what you can do when you use a meta registry that aligns across many different registries and adds extra content. So the bioregistry has a couple notable technical updates. So for everybody who's here the first time, this may be a little bit jarring because it doesn't have the history of everything, but some of the major things that we worked on in the last year is to externalize the functionality for parsing queries and URIs and compressing and resolving them into a standalone package that can be reused, not just by the bioregistry, but by any other code bases. And we've actually rewritten this code in Rust, which is able to be compiled into both Python, Java, R, JavaScript, and WebAssembly. So big thanks to Vincent Emine, who helped do this. And eventually we're interested in also extending this to PHP and Perl, because this is a very core tool set that have needs across every programming language. The way that we represent some of the prefix maps, this correspondence between queries and URIs, we've actually created a standard called the extended prefix map that incorporates not only the traditional prefix map, which is represented by a simple dictionary, but also incorporates the synonyms for URIs, URI prefixes and query prefixes. So this is very useful for downstream consumers. For example, the SESM package for mappings also is now using these extended prefix maps for its own internal standardization. So bioregistry is implemented in Python. We also made some Python improvements. We switched from using Pydantic 1 to Pydantic 2 to use some of the speed improvements there. We switched some of the tooling that helps us keep the database clean, but also helps keep the code clean and easy to maintain. There's an entire system of custom bioregistry deployments that we put together initially for the ASCIM project, I think. But we found that even the NIH was interested in doing this, and we've had other people interested in deploying their own instances of the bioregistry, also with their own prefixes in it that aren't necessarily useful for the community, but would be internally useful. So this might be something that you're interested in, and we could come back to that. Another feature that we added was a Sparkle-based IRI mapping service. So this works by when you write a Sparkle query that's federated, you may have two different resources using two different sets of URI standards, and the bioregistry can be the glue between those two things. So you can write a federated Sparkle query across resources using different standards. So again, Vincent helped with this a lot, and we were motivated by Jürgen Vodeman from SIB on this. And Well, this is something that in the polls people are quite interested in, is what happens when you disagree with the bioregistries as a standard and you say, I know that's the bioregistry standard for prefix, but I really want it to be something else. We've created a workflow for deriving custom community-based context from the bioregistry with OBO and Monarch Initiative as a use case, and Nico Matanzoglou really helped to push this forwards. So that's something that we also saw in the polls already. People were interested in how to make their own custom bioregistry derived prefix maps, so we can come back to that. And yeah, I already mentioned we did some Python improvements. And I think that the improvement to the SESM package for people who are working on mappings, it's more deeply integrating with the bioregistry now. So here's a really beautiful picture of a lot of different organizations and pieces of software and web applications, and also databases and frameworks that are using the bioregistry. We're very slowly finding our way into a lot of tools. I think actually one of the ones I'm quite proud of is the integration into the ontology lookup service itself. So if you go onto the ontology lookup service and you see some cross references, those are now linkified using the bioregistry. And I think that this makes browsing ontologies incredibly powerful because those cross references point to other resources that do talk about the same entity in a different place. In terms of notable content updates from the last year, one of the other organizations that we've worked with a lot is the German National Data Infrastructure Project, the NFDI project, and specifically the chemistry consortia within the National Data Infrastructure Project. We've added a lot of prefixes specifically for their use cases in the chemistry and the catalysis domain. And I just mentioned that the EBI is now using the bioregistry to solve some of these problems. And the NFDI project is also working with the EBI to improve the ontology lookup service, including some of these features. So this is something that had a downstream need that eventually made it into the upstream OOS. It's worth noting that Wiki Pathways and BridgeDB. So actually yesterday, if you were in the workshop for the community curation, we saw a Wiki Pathways talk. So Wiki Pathways is also now using the bioregistry in its front end to make outlinks to other places using compact URIs, and those are being linkified using the bioregistry. Yeah, and so one of the things about the bioregistry that I mentioned is it's a meta resource, and it's downloaded existing prefix registries like identifiers.org and reuse the content from those because it doesn't make sense to reinvent the wheel. However, by inheriting some of the choices of existing registries, we did cause a little bit of friction within some of the linked data community and the ontology community. And so one of the particularly difficult discussions about how to align many different communities with different standards was actually related to the way that people talk about enzyme classifications and enzyme codes. And so without unpacking that whole discussion, it was very interesting that a large community of stakeholders got involved to discuss what is the correct prefix for enzyme codes. I'm sure if you've done data integration anywhere in the biomedical space, you've probably run into enzyme codes at some point. They're very useful for classifying enzymes. And if you are in this space, you've probably seen them written in many different ways. So the bioregistry has a very interesting position where it's not a tool that can force anybody to change the way that they write their data or encode their data into their own databases. But it is a place where the community can come together and have discussions about if we wanted to standardize this, how would we do it? And how do we look at historical choices and maybe change those choices in a way that it doesn't disrupt a lot of people's content? Because one of the problems with making big changes in a standard is that everybody, if they want to follow the standard, would have to make changes in their databases. And so this is not realistic in a lot of scenarios. So if you're more interested in this, we can take a look at this discussion together. But I think that it is a testament to the fact that the bioregistry really brings a large community of stakeholders together and allows them to come to consensus on these things, and then provides both a technical and a philosophical backend for operationalizing those choices in data integration workflows and data standardization. Again, we also have worked on finding literature references and making a better way of connecting people who are publishing about various resources that are in the bioregistry. I think Ben's going to talk about this a little bit because this is using a simple but clever semi-automated workflow for doing this curation. So ongoing questions as I'm coming to the end of this background on the bioregistry is how can we prioritize curation in the bioregistry that would best support the community? This is a question that maybe by the end of today, you might have some ideas on how to answer based on what are your needs and what have I talked about that sounded interesting versus What did I not talk about that you think might be in this space, but you want to be able to solve? And one of the questions, depending on the group, if we might come into this, is how do we help maintain a community where, for example, this discussion about enzyme classification, this was a very difficult discussion to moderate. And when you have a lot of people who have a lot of history, how do we support the community and make it a place for respectful and proactive and useful discussions, especially on difficult issues? So I can say a little bit more about our governance. I already mentioned that we have this idea of open data, open code, and infrastructure. I presented on this, in fact, 2 years ago in the Padua meeting, also at the ISB 2023. And I think that this has been a very useful tool. I already mentioned this, and the fact that we've got kind of this wrapper of public governance around the bioregistry to help make sure that this project can be sustainable. The discussion channels that we use for this are all public ones. We use GitHub for code and issue tracking. We use the Obo Foundry's Slack, and to some extent, the overlap with the ISB's Slack is pretty high. We don't do any of our work with private emails because this is a good way to make a project start to feel closed and exclusive. So if you're interested in how we think about doing governance, we can come back to this too. I'm going to skip this slide. But what does it actually look like for the bioregistry team on a day-to-day basis? We have a public issue tracker where people are making requests for updates, for changes, for additions. And typically the bioregistry team just keeps track of that issue tracker, and we look at the things that people suggest, and we either give some suggestions, we help them to improve their requests, and then we incorporate those into the database. All right, so I think we're getting to the end of this, and then we can get to the lightning talks in the tutorial. The bioregistry itself, I've done a lot of hand waving, but where does this exist? How can you start looking at it, and how can you use it? We have a website, thebioregistry.io. If you are working in Python, you can pip install the bioregistry package and get access to all of its functionality. There is an API that can be used from any programming language in an agnostic way that's run with the Swagger API. So there's API docs in the website. The source code and the data are all in one repository on GitHub. Source code is licensed under MIT. The data is licensed under CC0. So this is always a resource that can be reused and forked in case of the need. And it is archived to Zenodo every time it's updated. So yeah, this is the way that we can keep the bioregistry possible to access from many different places. All right, the next step is to do some lightning talks. So I'm going to hand it over to Ben. Do you want to screen share from your laptop, or do you want to use mine?
So actually, we have two lightning talks. One of them is going to be by my student Mufaddal, who will talk about automated literature prioritization for curation in the bioregistry. And I think Mufaddal, if you unmute, let's see if we can hear you clearly in the room.
Yeah, can you guys hear me?
Yep. Yes. Yeah, sounds good. Do you want to do screen share, or should we run the slides?
I can share from my machine.
Okay, go ahead.
Okay, can you guys see that?
Yes. Yep.
Okay, perfect. Yeah, thanks, Charlie. So just to give you a quick introduction about myself, my name is Mufaddal. I'm a master's student with Dr. Gyuri, and I've been working on the bioregistry since last year in the fall. And I'm just going to be giving a short presentation about a semi-automated curation workflow for new publications and how to assess whether they should be included in the bioregistry or not. So what is the problem that we're trying to address exactly? Well, roughly speaking, there's about 5,000 or so new published papers per day in biomedicine alone. And the thing is that any number of these papers could be relevant to the bioregistry as a resource that assigns identifier information to entities of interest. And the task of manually identifying and curating these relevant resources at a scale this large is something that's quite difficult and a laborious task at this scale. So our goal is to essentially develop a semi-automated curation pipeline to not only identify, but also rank these relevant resources, which can then be manually reviewed and curated in the bioregistry if deemed appropriate. So what does this pipeline look like exactly? Well, the first step of this pipeline is to query all of the titles and abstracts of the selected PubMed papers with a certain list of keywords that you can see on the right over here. Really anything that just indicates the addition of a new resource that should be included in the bioregistry, so database, ontology, etc. And once we've completed this initial filtering step, the next step is to uh, feed these papers into our model, which is trained on two data sets primarily. The first one is the list of publications that are already found in the bioregistry inherently as part of the metadata for all of the various prefixes. These are all used as positive training examples. And the other data set we use is a manually curated list of papers, which contains a mix of both positive and negative training examples. And so once the model processes all of this information, the resulting output is a table of relevant papers that is scored by relevance. And so once we reach this point, we can actually commence with the curation in a slightly more efficient manner than just randomly selecting papers, for instance. And once we manually curate these papers as relevant or irrelevant, these can be again fed back into the model and be used to retrain it and hopefully improve the accuracy over time. And so when we're talking about the manual curation step, what we've done is we've essentially developed this controlled vocabulary of terms. And for the purposes that we're interested in, they're essentially used to distinguish between relevant and irrelevant resources. And when it comes to relevant resources, they generally come in three different types. The first one is a new prefix for the bioregistry, which is providing new primary identifiers. Uh, New primary identifiers. The second one is a new provider, which is resolving existing identifiers. And the third one is just a new publication, which can just be added to the list of publications for any existing prefix in the bioregistry. And just to walk through a couple of examples of what this has looked like in the past few months, this is an example of a new prefix for the natural product atlas. So this was scored by the model and ranked very highly in terms of relevance. And so I took a look at this paper, and after digging around, I was able to determine that it is indeed providing new identifier information. So I can create a pull request after going through that process with all of the relevant metadata that you see on here from this little screenshot of the bioregister page. And then this is another example of a new provider, which is curated in the bioregistry through the same process. These two highlighted ones for diagnosis and FERNA are specifically providers for PDP, which is the protein data bank. And so going through the same process of seeing that this has been ranked very highly by the model and then digging around to realize that it's resolving identifiers for PDP, I can curate them appropriately as a provider instead. And this last one is just an example of a new publication. So in the highlighted publications field at the bottom over here, you can see the 2024 paper for the RFAM prefix, which already existed in the bioregistry. And so this one is just a really simple case of updating the publications list to make sure that this resource is as up to date as possible. And so lastly, what I just wanted to what I wanted to talk about was comparing the model's performance to random sampling and keyword-based sampling. So what you're seeing over here in the blue bars are the percentage of relevant resources that were identified out of 120 or so papers in a 3 to 4 month time span. And so out of those 120 or so papers, about 5%, 5.5% of them were curated as new providers, 15% or so were curated as new publications, and 8.6% were curated as new prefixes for a total relevancy of roughly 30%. And when you compare that with random keyword-based sampling, which is shown in the red bars over here, that only yielded a 7% total relevancy, which is just the first step of that filtering process where we're looking at those specific keywords and not feeding them into the model for relevance determination. And when we use completely random sampling of papers in a similar time frame without any keyword filtering, that yielded absolutely 0% relevance, which is somewhat expected. And so we can clearly see that the model is doing a much more efficient job at identifying relevant resources that can then be curated into the bioregistry. And so the goal is that eventually, as we continue our curation efforts, we can continue to train the model and increase its accuracy over time and eventually develop an even more automated process in the future. Yeah, so that's all for my little lightning talk. A couple acknowledgements here, funding acknowledgements, and yeah, thanks to Ben and Charlie for helping me with all of this. And yeah, if you want to take over, Ben, for your talk.
Sure. Any questions for Mufaddal?
I have one question for that. So do we run into this bias problem where if we're using the predictions, we're going to, so first we're using these keywords to filter down by PubMed, and then we're training the model based on that. Do you think that there is anything we're missing that by kind of curating this workflow that we biased ourselves towards with these first sets of keywords? Like, what if there's like a seventh keyword that's the perfect keyword, we haven't found it?
Yeah, that's a really good point. So I think that I'm sure that there are other more important, not important, but there are other features and keywords as such that could help us to identify papers at a higher rate as well. But I don't think that this is something that can be like really intuitively recognized at the beginning. But what I have noticed over the last few months of reviewing papers or so is there are certain other things like the like whether a URL is included in the abstract of a paper, or if certain other keywords tend to pop up more frequently than they should they should probably be included in the list of keywords as well. But I think as more people continue to curate the papers and as we get a higher sample size, then we can slowly start to eliminate this bias if any, and hopefully get a more fair assessment of this as well. But I think it's just more of it takes time to identify any sort of patterns. And right now we're fairly early in the process, I would say.
Yeah, great. Thank you. Great work.
Thanks. Okay, so I'll switch over to the second lightning talk, which is also about a semi-automated aspect of curation in the bioregistry. So Charlie mentioned that one of the key drivers behind building the bioregistry is this meta registry aspect, where we harmonize across and import metadata from, at this point, 31 external registries. And one of those is like identifiers.org, but there are several others, linked open vocabularies, name to thing, and so on. You can see a few examples in the table on the right-hand side. And so this is also something that Charlie showed, how for a specific record like PubChem compound IDs, we would have a bioregistry record whose standard prefix is pubchem.compound, but that maps across similar entries from other external registries, whose prefixes might look, in some cases, similar, perhaps with different capitalization, or in some cases might look quite different from the prefix that we see in the bioregistry. And so this is what we call cross-registry mappings. So the fact that BioLink's CID entry is mappable to bioregistry's pubchem.compound entry. There's about 8,000 plus of these mappings. Looking at something like CABI on the website, if you go to the CABI record, this is what you might see. So you have the basic metadata about CABI, and then there's a section that's specifically about exposing these cross-registry mappings. And so you can look up the CABI resource in Aberal, in Bartok, in BioContext, BioPortal, and so on, right? Now, to begin with, a lot of these mappings are actually automatically assigned based on lexical similarity of the prefixes. And our baseline hypothesis here is that out of the 8,600 or so mappings, they are largely correct, but there is a small number, maybe on the order of 1 to 3% or so, that is incorrect. So, but reviewing 8,000 plus mappings would be quite challenging. And here's a specific example that we ran into a couple of months ago. So we have the human phenotype ontology, very widely used in the community, and there happens to be other ontologies that are unrelated, that are also called HP or HPO in some of these other external registries that can accidentally be mistaken as false positive mappings. And just 3 red boxes are corresponding to this. So for instance, one of them is the hypersensitivity pneumonitis ontology, also HPO. There's also a hyperdimensional polymer ontology, also HPO, and so on. And these were originally there in the bioregistry as sort of false positive mappings, right? And so the idea was to say that if you look at the name and description and potentially other metadata associated with these entries, as a human, it's obvious that they are not the same resource. But how can we do this in a more principled, automated, and robust way? We came up with a pipeline that relies on sentence transformer models on the metadata text associated with the bioregistry entry itself and the external registry entry corresponding to a mapping. On this HPO example, you can see how, in this case, we would have the bioregistry metadata text that kind of reads human phenotype ontology and its definition and so on. And then we would have the external registry metadata text. That's hypersensitivity pneumonitis ontology and its definition and so on. We run a sentence embedding model, which turns this unstructured text into a fixed dimensional vector. And then we can calculate the similarity between, the distance basically between those two vectors. And vectors that in this embedding space are close to each other are going to be more similar, and things that are far away from each other are more different. And so the idea is that low similarity scores could indicate a mismatch. High similarity scores are likely correct mappings that have the same name, same definition, and so on. And so we created a giant table of mappings with similarity scores. And the benchmarks look really good in terms of the performance of this approach. So a few different ways of looking at it. One is we had already a set of curated mismatches that we previously kind of manually recognized. And this approach allowed detecting 73 out of 85 of those mismatches. These are ones that ended up with a similarity score less than 0.5, which is actually quite rare in the big scheme of things. This is a distribution of similarity scores. You can see that 0.5 would be here. So the vast majority of these scores is actually much higher. And like 83, out of the 85 known mismatches, 73 were in that less than 0.5 range. And then we did a more systematic benchmark where we randomly sampled in a stratified way mappings, and then looked at how this model can distinguish between correct and incorrect ones, and got a very high AUROC and AUPRC score. And so out of that, we could actually quantitatively estimate that if we just curate all of the mappings or just review all of the mappings that have similarity score less than 0.6, which is just 300 out of many thousands, then we would expect to uncover 96% of all of these incorrect false positive mappings. So that's what we have just started. Mufaddal and another student, Nalika, have been going through some of these mappings, different ranges of similarity scores, and scoring them as correct or incorrect. And this will be expected to basically eliminate all of the false positives. We also came up with a new representation, a more principled representation for these curated mappings using the SYSM format, which allows us to curate both positive and negative examples, and then these flow into the alignment workflow that the bioregistry uses to update its resources. And then going forward, the idea would be to apply this kind of model, not just as a review tool to find issues, but something that we can apply upfront to align a new resource in the first place, especially if it's highly likely that in the future there will be new external registries that we want to align with the Bioregistry. And in those cases, we could now actually apply this model upfront to find potential mappings in a more precise way. Happy to take questions.
Not a question, but a comment. I think you said it was 73 out of 85 of the previously curated mismatches
Yes.
you were able to reconstitute.
Which ones couldn't?
And I think the ones that you weren't able to were probably ones to resources that didn't have any names or descriptions associated with them.
No, that wasn't the issue. It's actually that could have been the issue, but that wasn't the issue. The issue was actually that those were resources that were mapped to each other. And they were actually mismatches, but in really subtle ways. So for instance, there are two different Alzheimer's ontologies that are both called Alzheimer's ontologies. Their descriptions are virtually identical, but they happen to have been developed by two different groups and are technically two different Alzheimer's ontologies, right? That's one example. Another example is there were some other good examples that are really subtle. So it's like you could, but I can't recall off the top of my head. There's also like one that I recall where it's like a prefix called archive, like the preprint registry. And you know, if you look at the description of archive, yes, the wording is a little bit different, but this kind of embeddings model across these two mappings will think that they are very similar. But it turns out that if you precisely look at what kind of identifiers each of these resources look at, one of them is actually identifiers of topics in archive, and the other one is identifiers of papers in archive, right? So it's sort of two different identifier spaces, but like at the level of the metadata, it would be really subtle to differentiate between those. So those are some failure modes, right?
Yeah. Actually, just a little bit tangential to that, this is a problem that we have when talking about the Bioregistry quite often. There's a conflation between what is a semantic space. So Ben just mentioned that archive, you know, the resource, the database, it has papers in it, and those are assigned their own identifiers. And it also has keywords or topics in it, and those are assigned to their own identifiers. So the Bioregistry is keeping track of those identifiers, the keywords and the articles. And yet in a lot of places, we see conflation between the database itself, archive, the resource, and these parts of it. So keep that in mind. This is also something that we've run into issues with external contributors to Bioregistry and tried to develop some training material just to keep that in mind.
Cool.
All right, so thank you, Ben. Then
Sorry, I have a question.
Yeah.
I may not be fully understand, but I just wondering, like for example, if you detect some mismatch, those terminology or prefix, how do you coordinate them to make that modification to their prefix? For example, HPO. So you find like there is this prefix for H, like phenotype ontology, right? And you find another prefix with the same term. How do you like? Do you reach out to ask them to make the modification? How is the work happening after?
I mean, in the first step, no. In the first step, we just resolve it within the Bioregistry, right? So, but I guess in some cases we do start discussions about these things, right? So in some cases we bring up on GitHub, kind of in a public forum, a discussion about like, why is there a clash in names? Can it be modified and so on? So it's but then that becomes a kind of social process more than a technical process to reconcile these discussions.
So in that case, for Bioregistry itself, it just remove those conflicts or
remove the mappings. Yeah. So we are not. So for instance, those three resources that are also called HPO, those are no longer mapped to the human phenotype ontology. And therefore, any propagation of metadata from those external resources will not accidentally flow into the human phenotype ontology record. and will not be linked to that. So it sort of resolves this issue of a false positive mapping.
Can I add to that? So in this example, the bioregistry is biased towards the biomedical and the life science domain, and there are more useful and more well-known resources and less useful and less well-known resources. In this example for HP, human phenotype ontology is one of the gold standards.
Yeah.
And so if we had to make a decision, then the one that's more well-known will get to keep that prefix in the bioregistry. Now, it might also be the case that the other resources which have similar prefixes or overlapping prefixes, we may assign them a different prefix within the bioregistry, such that somebody who wants to standardize against the bioregistry can still reference entities, because we don't want to now exclude some other resource just because it's used the same name. But this is again, sort of a social problem to decide who gets the prefix that's the best one. And now in this situation, right, HP wins. We love human phenotype ontology. We want to use it everywhere. And these other ones, I think, are probably very useful in a very limited domain. But for which one do we decide in the bioregistry? It's obvious. Now, it's not always the case. And a great example of when this isn't the case is for the prefix GEO. GEO, what does it stand for? Matt, what does GEO stand for in your world?
I don't know.
Sorry, I didn't mean to put you on the spot. So there's the people in like the EBI and the NCBI circles who say, oh yeah, it's obvious, it's the gene expression omnibus. So you're aware of this? The people who are working in geography, they say, oh, no, this is the geographical entity ontology, right? And so this is part of the OBO foundry. And now we're actually at a place where there are two pretty well-known resources, and it's very hard to say who gets that prefix. Now, this is maybe a nice lead into one of the potential discussions for tutorials. What happens when you disagree with the bioregistry? Because at some point we had to choose who gets GEO. And the way that decision was made, I'll stand back up. That decision was made sort of by the construction of the bioregistry, that one of the original resources that seeded the bioregistry was identifiers.org. And identifiers.org had made the decision that GEO means gene expression omnibus. It didn't have any record for the geographical entity ontology. And so as we seeded the bioregistry, that was the reason why that choice was made. And this caused issues for people who are in the OBO world, because they expect that all of the OBO prefixes are the standard and everything else is a secondary standard. So how do we solve this problem when me in my project or my community, we have a disagreement with these choices that the bioregistry made? So that's one of the things that we can talk about in terms of tutorials. Let me kind of bring the slides back up, and then we can frame all of this. Okay, everyone can see this and still hear me? Well, thank you in the room, very good. Online, so still okay?
Yep.
Yeah, so this is for sure an interesting thing, and we can come back to this. However, that is getting into the weeds a little bit. So I want to offer a couple other things that we can spend the rest of our time together. And originally, we have 45 minutes left on the schedule if we want to be conservative and stop right when the coffee break is supposed to begin. So I think this is a good idea, is we stick to that schedule. We can go through some of these tutorials, or we can break into discussion and see what's interesting for you. So we could talk about this thing. What do we do when we disagree with the bioregistry? It's a very important thing for people who want to adopt bioregistry. But we can also talk about a couple other more basic things, which for the room here, because I see a lot of new faces, it may be interesting for us to together go through the bioregistry website and look at some of the examples that were shown in the slides before, and just get a feel for what really is this website and how do I use it. We can go through the way that you can submit new prefixes to the bioregistry through GitHub, and we can walk through that tutorial together. We can give a little bit of insight into how do we review a new prefix request. So people like Ben and I are typically doing this, and some of the others on the review team. We could talk about these curation workflows that Ben and his students have presented, and how do we go about doing that, or maybe just looking at the resources if those things are interesting to you, to see like so how some of this practical curation is working. But on the other hand, this may be a group of people who are more interested in hearing, what can the bioregistry do for me? I don't really mind, it's curated and it's nice, but I can just go ahead and use this. So we can also talk about what does the Python package for Bioregistry look like? What are the functionalities that I can start using immediately in my code as like, you know, a data scientist who works with pandas and RDF lab? We could talk about what it looks like when you want to download some data from, let's say, I'm going to use the complex portal as an example. If you want to download the data from there, how do I standardize it in a way such that I can reuse it and deal with like, you know, data science in the real world? Even from excellent high quality resources, there's still a need to do some standardization. So what does that look like? Another opportunity is if you're interested in doing data models, if you've like thought about using LinkML before and thought, wow, this is way too heavyweight and complicated. I just want to write Pydantic models and, you know, make a quick little Python data model. Bioregistry is going to support you in doing this in a very lightweight way. We can go through that if that sounds interesting. We can go through just a list of what's downloadable from the Bioregistry and what can you like put into your local drive and start using in your own files. And, you know, we already talked about this. How do I make my own versions of the Bioregistry that are a little bit different with my standards from my community? How do I extend, remap, rewrite some of the content there? And if somebody's interested, how do you deploy your own copy of the Bioregistry, potentially based on your community's version of prefixes? So yeah, I stop right there and kind of leave it open to the floor or online if anybody has something that they specifically want to look at. Otherwise, I would say maybe just doing a quick walkthrough of the website and showing a little bit of Python coding would be a way to get everybody's appetites whetted. Maybe before doing that though, like I can ask a little bit about the room. So who here is doing biocuration themselves? Like, and they maybe maintain a database or contributing to a database? Okay, good. Almost everybody. That makes sense. Does everybody in their database, do you create your own entities? Like, for example, are you UniProt, where you create entities for each protein, or do you reuse the entities from somebody else's database? So everyone who like makes their own entities, all right, and everyone who's like reusing entities. Okay, good. Bioregistries for both of you. So let's start with this. Everybody who says that they make their own resources, can someone call out what's your resource?
We use mesh.
Mesh. Okay, so we can go to the bioregistry.io right here, and we can look for mesh. So on the front page, we've got a prefix search. The good thing is mesh is an acronym, and most prefixes correspond to the acronyms of resources. So if I type in mesh, we can get lots of things. So here's a, you know, the search could be better, but here's the page for mesh. A Bioregistry page has the title of a resource. It has some description of the resource. In some cases, it has an image or a logo to go with it. It has all of the alternate prefixes, these synonyms we talked about earlier. I think if you downloaded data that talks about mesh, you've probably seen there's a huge variety of ways people refer to mesh. Some people have these little extensions like MESH-D or PP because they're talking about diseases or processes. Sometimes people talk about UIDs or UIs. It's really wild what you see out there. Here's, you know, people using mesh with some dates attached to it. A given bioregistry record also incorporates some keywords. It has licensing information and some links. So mesh just has a link to the homepage. When possible, we try and keep contact information for single points of contact, though for resources like mesh and some other large ones, sometimes it's difficult to find single person contacts. It's important that the bioregistry keeps track of what are the identifiers looking like inside mesh. So we have a regular expression string that helps you validate the given identifier coming from mesh, and then also a couple examples of those. And once you have the examples, the last thing, which is a little bit further down, is we keep track of what's the URI that can resolve an identifier for mesh into a URL, like make a URI out of it. So that comes down here. So given this mesh ID, you can create a URL. And so all the way back up to the top, we can take these examples and we can like resolve them and turn them into a web page. Now, it wasn't possible to see because I just clicked the link, but the bioregistry itself has a way of constructing URLs based on queries. So I hope this is okay for everyone to see, but if I type in bioregistry.io, and then I type in the query for a mesh identifier, like mesh C063233, the bioregistry will make a redirect that goes to the correct page. So therefore, you don't have to keep track of what is the URI that makes mesh IDs. You just have to know mesh is the name of the resource and it's the prefix. So we can create a query and then we can create a URI based on the bioregistry. And then, yeah, we get a redirect. Some other things. So we mentioned the publication workflows. We also keep track of all of those. If you weren't aware, MESH is a very, very old resource that was published in the 1960s for the first time. This is a wild old publication. Would suggest reading it sometime. It's very cool. It's like been OCR'd. Yeah, and we also keep track of who's made contributions to a given record over time and made improvements. So Roman Baum is one of the guys from the NFDI project that was able to help improve this record. A given bioregistry record can have some or all of these things. And there's also other ontological information that we keep track of that connects different records in the bioregistry. For example, there's historically a record for the chemotoxicogenomics database. No, sorry, it's a comparative toxicogenomics database, CTD. And so a long time ago, I think we inherited this from identifiers.org. There was a prefix for ctd.chemical and ctd.disease, but it actually turns out that these were just reusing mesh identifiers. And so we're able to like resolve these things. And so in this way, ctd.chemical is not just a synonym of mesh, but it has a little bit of extra information associated with why it's a synonym. This is also not a very good thing, but there's other prefixes that we inherited from identifiers.org that have a mesh plus the date, because I don't know, maybe there's something special about the 2012 or 2013 editions, but we're also able to map those back to each other. And in some cases, there are related vocabularies. So mesh.vocab is another prefix. Let's check that one out. And this one's related to the RDF vocabulary associated with mesh. So this record actually has a lot less information associated with it. It's missing contact information. It's missing a pattern for its identifiers. In some cases like this, it's actually hard to come up with a pattern for identifiers because they're kind of like ad hoc namespaces that just use more English looking labels or more natural language looking labels rather than principled identifiers. Okay. Next thing on the mesh, back to the mesh record, what Ben mentioned is we've got this meta registry, the links from Bioregistry to other places that talk about mesh as a database itself. All of these things are talking about the metadata associated with mesh and not specifically the mesh resource. So one example, which is a good one, I think, is fair sharing. The goal of fair sharing is not to talk about semantic spaces, but to talk about databases themselves or ontology artifacts. So if we follow this fair sharing link, we'll go to the external website and we'll see what fair sharing has to say about mesh itself as a resource. So first of all, it classifies it as a terminology artifact. And it also has some similar overlapping metadata that Bioregistry is interested in, like a description string, for example, on a home page. Okay. The next thing, which each resource keeps track of, and this is a little bit in the weeds, but there's a difference between web pages that we want to look at and also the way that entities should be encoded in RDF. And if there's a specific way that we should write URIs when we're using RDF and doing semantic web linked data things, Bioregistry is able to keep track of this specifically. So Mesh has its own way of specifically writing its URIs in RDF, but when we're humans, we don't want to look at the result of using that URL. So we actually have a way to keep track of both of them at the same time. So when we make a redirect, we show the human page, and then if we're doing some kind of data science applications, we'll want to use the semantic web version of this. Just as a historical note, figuring out that this needed to be part of the Bioregistry wasn't like part of the original plan. This was something that we found out that people really had a lot of nuanced opinions about the way that we talk about URIs and URLs. And this was something that we added and we're able to curate in many cases to make it more consistent, the way that we're doing data integration. And then the last thing, which also was mentioned very briefly, is that Mesh itself is a resource and it has its own web pages for its entities, but there are many resources where an external database or an external website has pages talking about the entities in that resource. So we'll also keep track of other providers. And earlier we talked about, I think Dionysus was one of the examples for the PDB, but here for Mesh, it's possible to get many different web pages that provide information for mesh terms. And so one of them points to bio to RDF. So if we follow the bio to RDF web page for a given mesh term, we get some information from their database. Mesh itself also has a couple different flavors of ways to get information for a given mesh identifier. One of them is a web page, but there's also ways to get linked data representations of mesh content, either in JSON LD format or in the n-tuples format or turtle format in RDF. And so I think these are the ones that Roman added onto here because they had a use case for this. And so it's also possible, and this is not a well-publicized feature in the Bioregistry, that if you have one of your Bioregistry links, so I'm going to write on the top of here, we go mesh C06 to 3233. You can actually add a couple of extra fields to this. So you can say provider equals, sorry, I can't see on top of my Zoom information what I'm typing. Give me 1 second. So we can say provider equals, and then we can type mesh .n3. So that corresponds to this code right here. And so now it knows, rather than just directing to the human web page, we can say, I want to use this provider and give me the information associated with this one. So let's click this. And now we've got some linked data in the N3 format associated with this mesh term. And we didn't have to know ahead of time really like what is the URI string for this. You just have to know that the Bioregistry keeps track of a couple different flavors of mesh that can be resolved. Okay, that's, sorry. All right, so that's what a registry page looks like for the Bioregistry. Now, if you want to find something and you're not quite sure what it is, you can always come to the registry page and use the search. So anybody else want to say one of their resources that they're maintaining?
OBA, ontology biological attribute.
Sorry, OBA?
Yeah.
Okay, so let's use this as, there you go, type for biological attribute, and here's ontology for biological attributes. So inside here, same idea, we have a lot of information. Now OBA is part of the OBO Foundry, which means that it's also got some extra metadata associated with it, such as the repository where it's curated, and download links to artifacts like the OBO export, the OWL export, and the OBO graph JSON export of its ontology. So for downstream users, people who want to do data science, I often find myself looping through the entire Bioregistry, getting the list of all of the ontology URLs, and then downloading them and making some extractions.
There was another request for Soybase.
Soybase, okay. Here's Soybase. This is, I saw Jacqueline's on the line, so this is your resource, and it's good. So if anybody realizes they need to get in touch with Jacqueline for Soybase, this is one place they can figure out this is who she is. Yeah. All right, so any questions so far?
I have a question. I'm online. It's Jacqueline.
Hi.
I'm in this just because I was interested and I was like, oh, look, Soybase is on here. But half of this is wrong.
Half of this is wrong.
Yeah.
All right. What to do when the Bioregistry is wrong?
Yes.
I think that we're going to click the big suggest button and see where it takes us. Are you ready for this?
Oh,
So,
okay.
the Bioregistry is curated on GitHub. And so if you're not familiar with GitHub, that's okay. It's possible to use GitHub even if you're not a programmer. It has an excellent issue tracking system. And even better is it has a way of having issue templates that you can even pre-populate. So you can see here that we've gone to a page and it says update Soybase. It says what the prefix is. And this is our opportunity to write down what's going on, what needs to be updated. So Jacqueline, would you like to tell me what we should update on Soybase? Or I could even challenge you to make your own issue.
I'll make my own issue because I'll go through it and add a whole bunch of info. I'm really comfortable with GitHub, so that's not a problem. I just didn't know what the suggest button did, and I was like, how? So thank you for showing me. I appreciate it.
Good.
Interesting to just look, if you go back to the Soybase page and we look at the meta registry, right? So it's actually likely that a lot of the metadata that's in here was automatically propagated from these external sources, right? So it wasn't something that was directly curated in the Bioregistry.
Yeah.
And it can be overridden in the Bioregistry, but it's like probably coming from these external sources that might have issues with their
Related to what Ben just said, so yeah, it's possible this information is coming from different places. Debugging this is not possible from the front end. You actually have to look at the back end. However, there is a secret feature which I've piloted. Some of these fields have question marks next to it, which can give you some extra information. And for example, if you click on the links, it says, hey, do you want to get programmatic access to this? Here's the Python code that you can use to get this data. However, on the name, this is where I've piloted this, I've added information that figures out where the annotation comes from. So Soybase's name is originally annotated in the Bioregistry. So this means at some point that I overrode some of its imports to be Soybase specifically. In some cases, this title comes from somewhere else. And so Ben mentioned maybe the description is wrong or there's something missing that might have come from somewhere else. And so we'll make it easier to debug that in the future. But that doesn't matter too much. It's still totally valid to make a suggestion. And the value of the Bioregistry being this meta resource is we can always override things. Potentially in the future, we could even contribute these kind of overrides back to the original resources to help keep, for example, fair sharing more up to date. And we have given the information to other registries that if they want, they can proactively pull our information because it is all licensed CC0. Some of the other resources that we're using are also CC0 licensed, and that's very good. And some of them have a little bit different licensing, which makes it a little tricky, but okay. Any other questions? Yes.
So, very nice talk. Just want to ask that I have 7 resources. Okay, but I can't see any of them here. So why?
Why not? So yeah, the question why this also is why are resources in the Bioregistry versus resources that aren't in the Bioregistry? So the Bioregistry so far covers things that are either in existing registries that we map to or resources that myself, Ben, or other people in the community have said, this is a resource that I created, or it's important to me for my use cases, and I want to be able to standardize. And people have proactively added external content to the Bioregistry. So in the situation where you've created some resources and they're not in the Bioregistry and you'd like to see them there, I think this is the ideal segue into talking about how to submit a new prefix. And we could, for example, use one of your prefixes, or I've also prepared a new prefix request. So the answer to your question is you can make a submission and we can also help with that sort of thing. So let's take a look at what that actually means. So one thing we can do is we can go to the registry page and, oh, okay, we can't do it. I thought there was an ad.
Anyone can request a new prefix. There's a link there. The previous page you were on.
Anyone? I tried so hard to make this, obvious that I didn't even see it myself. Okay, so we can request a new prefix. And again, this is going to bring us to GitHub. So can I get a show of hands in the room, like who's comfortable with using GitHub? Excellent. So for the most part, this is pretty straightforward. Like I said, you can make a GitHub account and use it to interact with the issue tracker without understanding anything else. So what does it mean to create a new prefix? First, we have to decide what the prefix is. So I'm going to actually, let's use my example for now, since I'm already kind of knowledgeable about it. We can more quickly go back and forth. I'm going to take a website that I hadn't been aware of until yesterday, the Unicarb DB. This is a SIB resource that was mentioned in the community curation discussion yesterday. And it occurred to me, this is not, sorry, we're looking at the wrong pages. So this resource isn't in Bioregistry, so how do we add it? The first thing is we have to decide what's the prefix. So gut feeling from the room, what prefix should we use for Unicarb DB? Not a trick question.
DB.
Unicarb DB, excellent, thank you. So yeah, did I make a typo already? Oh, I did it right the first time and I broke it. Okay, so Unicarb DB. What's the law that shows like when you start doing things in front of people, you make typos like every time? I never make typos and then, I'm in front of a group. Okay, so we decided Unicarb DB is the prefix. Most of the time, this is pretty obvious. We can write it out in full as the name. The homepage for Unicarb DB. Well, I'm already on the webpage, so I can figure out what the homepage is just by doing some copy pasting. I don't think it's the case that this is a resource that's curated on GitHub. So we don't have to write anything about a source code repository. A description. So I'm a little boring and I'm not sure if this is right or not, but sometimes I've gone and you can usually copy paste the description and I'll write something like from homepage. Yeah, so usually their description is a pretty good one. And let's see if we can very quickly figure out what the license is for this resource. Luckily, they say on the bottom, it's licensed CC by 4.0. That's good. That means that it's very easy to reuse. They have got a publication. So this is an optional field, but we can figure out what's the PubMed ID for this and quickly incorporate it. Okay, next, the Bioregistry really wants people to know what a local identifiers in the resource look like. So right now I'm looking on a page for one of the glycans or one of the structures that's incorporated by this resource. And it looks like this URL with the 91 at the end. The 91 is actually the identifier for this structure. And so that's going to be the example local unique identifier. In many resources, numbers are used as the local unique identifiers. In some, like Mesh, for example, there's a letter, either D or C, followed by some numbers. And some resources use other kind of more complex strings like ISBNs. We were talking about these yesterday. They're numbers with some dashes in them. ORCID identifiers also have some dashes and some alphanumeric characters.
Okay, can you remove the space on after PubMed colon?
Thank you. Yeah. Okay, the next thing is if we have a pretty good understanding of what the identifiers in the resource look like, we can provide a regular expression string. And I already looked at a couple and it's a pretty good guess that all of the identifiers in this one are going to be numbers. This isn't always the case, so just be careful. And I'm going to provide a regular expression for what a number looks like. So regular expressions start with the caret symbol. That means this is the beginning. /D means it's a number, a digit. And plus means one or more of that thing. And the $ is end of the regular expression. All right, the next step is to have the URI format string. And this is optional. Not every resource can be resolved. However, the most valuable resources do have some kind of web page that lets you get information about their entities. And so we want to keep track of the type of URI that can be used. So again, we're going to come back to the web page and we're going to keep almost all of the URL, except the place where the identifier goes, we're going to replace that with a placeholder, the $, and then the number 1. Has anybody ever asked why do we use $, and number 1? This is just a kind of a pseudo standard that semantic web people use. So yeah, because $ don't typically show up in URLs. So that's why we use $1 to represent where the identifier goes. Now, there's a couple other places we can look to link some more data very proactively, but I think we're going to skip looking up the Wikidata property. I don't think there is one, but you know what? Let's just look anyway. So I can go to Wikidata and I can look up unicarb DB. And I see that there's a database entry, but it doesn't look like any of these are properties. So there's no Wikidata property corresponding to this. However, for example, Kebi. Kebi has an entity in Wikidata for its database, but if we look specifically for properties, there's a property that connects a given Wikidata identifier to a Kebi identifier. So that's what we would use here. Don't worry about this. This is something that we can always improve on after the fact. Okay, now the last step is to say who's the contributor. So I'm going to put my name here. I don't know what my ORCID ID is, and I can't copy paste it from the example field. So in every request for making additions or changes to the bioregistry, we do ask people for their ORCID IDs because we're able to contribute, we're able to keep track of who our contributors are. We're able to give people credit, both on the technical level, like on the web page, on the website for Bioregistry, we keep track of all the people who've contributed. When we make publications, we email all the people who've made contributions and say, hey, you helped, do you want to be a co-author? And yeah, I think this is a very simple way of doing all these things. And if you've heard from the Apicuron crew in the last couple of days, we also send data about who's done contributions to Apicuron, so they can also keep track of it. All right, that being said, I've written down my information as the person who's making this new prefix request. It's also possible for me to write down who is the contact person for the resource itself. And I think there are two people responsible for Unicarb DB. It's Frederic and let's see, who's the other person? Typically, websites have an about page, and then they have information like this. Here are our contact people. So this is very good. This is public information. So I'm going to copy the email address, write down the contact email for Niklas Carlson. I'm going to add the name. These are optional fields, but it's very useful to have this information. And typically, you're going to go to ORCID and you can search for that person and see if you can find the right ORCID ID for them. So this is in University of Gothenburg, and this looks like the right person. So here's the ORCID ID for Niklas Carlson. We can also go one extra step and try and find the GitHub information for people. So you can do that by going to GitHub, searching for the name, and seeing if you can find a user with a person on that name. The reason that we keep track of this information on Bioregistry is because you might want to reach out to people and say, hey, I want to make an update to the Bioregistry prefix about your resource. You probably want to be part of this conversation. And then you can ping them on GitHub. So I don't know if this person has a GitHub account that will be easily able to find. So better just move on. And any additional comments about this database? Like for example, you can say something like, I didn't know how to find this field. I can say, yeah, I looked for the GitHub handle, but couldn't find it. Okay. Any questions about what we did so far? So we filled out the new prefix request. Most of the pieces of information on here are pretty straightforward. I think it's a little bit confusing the first time you're looking at this to sort of understand what the URI format string is related to like the URL that lets you look at the entities. But each of these has a little bit of an explanation below it.
How many of these fields are mandatory? And if I didn't know that or couldn't work it out, I could leave it blank? Or...
Each of these has a red asterisk next to it, and it has form validation. So if you forgot something that's required, it will come back. But the only things that are really strictly required are the prefix, the name, the homepage, a description, and an example local unique identifier. If you can't show that there are identifiers for this resource, then like it doesn't make sense to keep it in the Bioregistry. Everything else is optional, but it's nice to have. So last step, this is a GitHub issue, so we just hit create. And yeah, then we get an issue in the issue tracker. And so it'll reflect all of the things that we've written. And this is a place where conversation can now begin. As project managers, Ben, myself, or Tiago, or Tiffany may decide to assign this to somebody to keep track of it. So maybe I can assign myself. Well, okay, I shouldn't assign myself from my own prefix. So maybe I'm going to assign Ben. You can see that we've got these labels for new and prefix. So if we do go to the issue tracker, we can quickly search for other new prefix requests, or we can even look at old new prefix requests. Now, the secret sauce of the Bioregistry is to try and reduce the amount of friction it takes to make a contribution, which means that requiring people to interact with the guts of Git and GitHub, or having to write code or work with the JSON files in the Bioregistry themselves, we want to make sure that's not necessary. And as I'm stalling right now, we have a GitHub action which said, hey, somebody just made a new prefix request. Why don't we make a nice pull request for them? And if everything worked out, we can go to the pull requests, and we've already got a pull request created by GitHub Actions, add new prefix for Unicarb DB. And here we go. This is what a pull request looks like on GitHub. And for those who are a little bit less comfortable with GitHub, this is when somebody actually wants to make a change to the contents of a repository. And even though we haven't looked at what's actually inside the Bioregistry repository yet, inside this repository, I mentioned that there's the code that actually runs the Bioregistry's web app. There's the code that maintains the data itself, and the data itself is in there as a JSON file. Now, a GitHub pull request is when somebody wants to make a change, and you can see that it closes the issue that I created in the first place. And so why don't we take a look at what are the actual parts of the repository that changed by going to the Files Changed menu. We can see here that we've now just basically added, there's a file called bioregistry.json. That's the database. There's no tricks here. It's just one file. And this pull request now adds all the things that I put into the issue and it formats them in the correct way to make it part of the bioregistry. So you can see we've got contact information, the contributor information is something that I put in, and you can see it's structured in a certain way. It also keeps track of the issue that we made originally, so we can link back to this later. All right. Ben, can I put you on the spot? So, well, I'm going to put you on the spot for that. Do we have any questions about what this looks like, what's going on here before we move on from making a prefix request to doing a prefix review? Okay. Do you want to screen share and you can just go through the review process, or do you want to do it for mine?
I don't know if that will take a little bit of additional work that we might not want to do live, but basically what I would be looking for to review this is review everything that's in here for accuracy and think about things that might be missing, right? So one thing that I would probably update is the description. So Charlie copy pasted it. This is a good first step from the homepage, but usually one thing we want to have reflected in the description is something that describes what kinds of identifiers are used in the database, like what entities do the identifiers actually refer to? Are they referring to small molecules, protein structures, whatever it is? So that is good if it's explicit in the description. And we can probably remove things that have to do with the history of the database, for instance. So I would update the description. I would usually look at the contact, is there anything missing? And then the publications here, the PubMed ID here is a kind of starting point, but usually before we finalize a record, we try to complete that and add any other identifiers that we keep track of, PubMed Central, DOI, for instance, as well as some metadata about the publication, like title, year of publication. There's actually an automated workflow to fill in that information, but this would not be complete at this stage. When I do review, I always check the URI format and make sure that the example identifier that is put in here can actually be resolved, that it links to the intended record. And then finally, one of the things that we always look for when reviewing these is, okay, so this entry, it refers to a specific type of identifier within this resource, but often databases are structured in a way that they contain identifiers for multiple different types of things. Very widely known example is PubChem has compound IDs and substance IDs, right? Those are two different sets of identifiers within the same database. And so often what we find is that, okay, it's good to have a record for Unicarb DB, but what if there are multiple different identifier spaces within this database? Then we want to go back and kind of resolve that. I don't think that's a concern here, but it's something that we would look at upon review, right?
So follow up to that is, how do we change the prefix itself when we realize there might be multiple different kinds of entity types? So originally we said Unicarb DB. This is the name of the high-level database. But if we found out that within Unicarb DB, we both got structures, which is what we did here, and maybe there's also their own, I don't know, keywords or something, we might change this to be Unicarb DB.structure and then have another prefix called Unicarb DB.keyword. And as reviewers, typically we proactively might go and curate a second record within the same pull request. So they're logically grouped together in one pull request that we can look at the history over time.
Yeah. Well, if you want to do that, I guess there isn't that much work involved, right? We could actually do this live.
All right, let's do it.
So it will just take a minute. So the only thing I don't know offhand is, how do we automatically fill in the publication info?
We don't automatically fill that. That's well, there is a script that you can, but it's going to be slower than just doing it by hand.
Oh, I see.
Because the PubMed API is slower than just looking up the page and copy pasting things.
Okay, then I'll, do you think it's worth doing this, or should we not?
Well, let's move on. I think that you got, one other thing that goes on during this process, there's one other field, by the way, Ben, which you didn't say, is we actually keep track of who did the review on each record. So at the end, we might have the contact person, the contributor, and then also the person who did the review. And, again, this is useful because if there's something questionable, or we just want to circle back to it, you might say, okay, who reviewed this? What were they thinking when they looked at it the first time? Now, in addition to all of this manual checking over. We have an entire testing suite for the data integrity of the bioregistry. So this checks stuff like, these fields that are required are there, and there's no funny characters that break the JSON file, and you didn't choose a prefix that already existed or overlaps with something else in sort of a non-trivial way. And this is really helpful. So those all get triggered in the pull request and after you make the review. And then we use the CI/CD system and it checks all these things. And so we're not able to merge the pull request until those things have all passed. Okay. Any questions about the new prefix workflow? So we already started in front. You've got 7 databases. That's maybe 7 prefixes you may want to add to Bioregistry. And we've still got, well, we've got 8 minutes left. So we may want to do that together, for example, during the hackathon and datathon time later. I hope that if anybody else is in the room, has a database, they're going to check and see, is it in the Bioregistry already? And if not, maybe try adding it. If you're not comfortable with adding things yourself, Ben and I are here. We're happy to work with you to show you how to do it, or to just hold your hand through it or do it for you. So we've got 8 minutes left. I think the last thing that would be the most valuable thing to do is actually just show you a little bit about the Python package. And then anybody who wants to see some of the tutorials that I mentioned, we've got some text already written about several of them. We've got some YouTube videos of us like just actually doing it. And Ben and I are here all week. We're happy to talk about this and help you to maybe, for example, make your resource look better like Jacqueline's going to do, I hope. So the last step will be the most harrowing part of anything, which is to do a live coding demo. So I've already installed the Bioregistry. So why don't I start up Python and let's import the Bioregistry. The problem that we started with is like, can we just solve this problem with all the queries and the prefixes being wrong? The most important function that I'm using all the time is bioregistry.normalize prefix. And so if I type in like, I don't know, what's a good example? So if I type in CID, this is the one that's going to get standardized to PubChem. And I want to see that if I've got some data set and I've got prefixes that are CID, I want to see them get fixed. So CID gets turned into pubchem.compound. Well, maybe my data set actually has queries inside it. So I want to try and normalize a query. So I've got CID 1, 2, 3, 4, 5, 6. And the normalized query function is going to see, oh, look, there's a colon in here. This is a query. Why don't I fix the part that's before the colon, which is the prefix? So now I've got pubchem.compound. What happens when I have a really malformed thing? We don't get anything back. And if I want to make my code raising an error when this is happening, I can do strict equals true. And then I'm going to get a prefix standardization error. Nope. No. You can't standardize that. It's not part of the Bioregistry. Another thing that we can do is we can do bioregistry dot, oh boy, I think it's get IRI. And let's do that for CID 1, 2, 3, 4, 5, 6. And it takes my query and it turns it into URL. So within your code, you can already start accessing this functionality from the Bioregistry if you're using Python.
Does Bioregistry still have that get function? Just do the get.
.get?
Dot get, say taxonomy.
I think that is a very old function. We may have renamed it. I think the get function got renamed into get resource.
Oh. Your website still using that.
Thank you for finding that. I'll have to update it. So those first functions were normalizing data, but if you want to get all the information about one of these resources or the records in the Bioregistry, we can use this get resource. And so, well, this isn't very nice to look at inside the REPL, but we have a class that represents all the information associated with taxonomy, which actually, by the way, gets standardized to NCBI taxonomy. So it's got the prefix, it's got the name. Interestingly, this class represents the content of the Bioregistry file. So here we can see the description is none. And the reason why the description is none here is because this record also contains all of the mapped information from external registries. So rather than curating an additional description we have to maintain ourselves, we just say, yeah, the other resources that we've mapped to also have good descriptions. So we just reuse those. So let's do this one more time. Let's store this as, we'll just call it resource. And if we do resource.description, we can see we get none, but there are also getter functions associated with this, like get description, which go through and check all of the alliance data. So when I write this, now we're going to get a string that's actually useful. Now for Matt, who motivated me yesterday, what if we had all the patterns for all of the regular expressions, for all the resources to put this into your new extraction pipeline and you're at PMC? Would be nice if we could do get pattern and then get, here's our string. Now, you don't have to always get the resource first. There's also top level functions for getting most of these data. So you can do bioregistry.getPattern. And then we can also type in taxon, or it resolves the prefix synonyms. So we'll also get this, keeping in mind that this standardizes it to NCBI taxon. Same thing as before, we can also do get description. And it kind of deals with looking up, standardizing the prefix first, looking up the resource, and then getting the alliance data. Okay, so we have just a couple minutes left, and I think it'd be nice if we finish on time. Anything that now that you've seen, there's a little bit of Python code here, like there's a function you really wish you had all the time, maybe it's there. You can ask me now, and if it exists, I'll show it to you. And if it doesn't exist, it'll exist by the end of the day. All right. Well, I think.
Sorry, this might be, something that is actually kind of external to the bioregistry, but the reverse mapping from URIs to queries, right? That's I think something that is really useful for people.
Yeah. So
you often come across URLs or URIs, and you can actually reverse engineer those into queries.
Good. That's a great. So here's the function that Ben was just talking about. What if we have a URL or an IRI and we want to parse it? We've got the parse IRI function. This might take a second to warm up the cache the first time that you run it, but in the end, it parses it really good. It gives you back this named tuple data structure, and it's got the standardized identifier, the standardized prefix and the standardized identifier. And then it's up to you what to do with that after. Okay. So we had a very ambitious agenda today, but I think we gave a good background on why the bioregistry exists, maybe how it's related to your work. We talked about what was on the website for the bioregistry, a little bit about how we do curation there, and how it can be used in the backend. We didn't quite get to using this in a language agnostic way with the Python. So I'm showing you Python code right here, but most of the functionality I just showed also has API endpoints that are part of the bioregistry's website. So if you're working from a programming language that isn't Python, then you can still use this functionality. Yeah, so I think this was a really great introduction. Thank you for the good questions. Thanks to Ben and his students for the presentations. We're gonna finish now. If anyone wants to chat, we have the coffee break, or we can do some final questions before we wrap it up.
No more questions. Great.
The discussion here, or leave it on?
Well, nobody's speaking up so far, so good.
Come back in a minute.
Oh, hi. Hi. Yes.
Of course, nice to meet you. Finally, in person, we only seen each other on Zoom, I guess.
Yeah, oh, you're also working on that, right?
Yes.
Perfect.
Several things. Yeah.
Well, it's nice, nice work.
Thanks.
Yeah, so hold on.
Well, the bioregistry, I guess, started in 2021 or so.
The bioregistry started in 2019 during my PhD.
Wow, okay.
It wasn't called bioregistry.
It was called the meta registry, and it was part of the Iowa package. And in 2020, I separated it out into its own package. And we started working on it together in 2021 or 2022. So it's, it's this very, very long set of problems that have been solved one at a time. And I usually talk about this like Dante's Inferno. I don't know if you're familiar with this. There's like this parable of the many levels of hell. And the further down you go, the worse of a sinner you are. And the bioregistry is really the bottom pit of hell as far as doing like biomedicine, because I want to be a drug discovery chemist. And now I'm working on how do we integrate data together and make sure the identifiers are the same. This is absolute
Well, this is a very important foundation work. And also, and all these different sources, and really, you need to put them all together. Right? Even ontology, right? The ontology, right? So many different people working on the ontology. Right? I think it's kind of mass, right? Yeah, so somehow you guys can think about unify all the effort and then.
There's also, Charlie alluded to this, but the sort of next level of complexity is, okay, so we know how to use identifiers. We have all these metadata about identifiers individually, but then these overlaps between the different resources, like disease ontology versus MASH versus ICD-10 versus, right? Is that the whole question of semantic mappings across resources? That's also something that we're working on, and it's very difficult because the way mappings are made available to other resources from each resource is completely ad hoc, right?
And all the mappings also have issues with standardization, which is actually the original motivation for the bioregistry, was to standardize the mappings inside the OBO ontologies and other ontologies, though it's much more likely applicable than its original use case, which is why we spent so much effort on it, besides it being part of some other repository for PhD.
Have you talked to the different database managing, maintaining, updating ontologies, and what their thought on? They have so many different competitors, and then how as a community, right, to do a better job at this.
It's not the job of the bioregistry to resolve the
I
competition.
know, but since you guys are kind of.
But for example, I think we can show the OBO community assessment. So the bioregistry, you can loop through every record and say, hey, which one has an ontology resource? And then we download each ontology and we go through and make a statistical assessment of how standardized are all of the cross-references and the things inside here. And then we can report back to those ontologies, say, hey, you guys have curated all these cross-references, but they're really unstandardized. We have an actionable way of standardizing them. And in some cases, we've written scripts that go and fix things. In some cases, there's like 3 references that just had typos, but there's no tools that existed already that were checking for typos and cross-references. So we go through and do the drive-by curation, where you make a very small pull request that changes 5 characters. And who knows, the impact of that is massive, because people build software systems on top of these ontologies that build, clinical systems, and every one little improvement can have a huge effect. And we've done this not systematically, since this is an incredible effort, but for resources that we found useful in our other work, which is building knowledge graphs and doing drug discovery.
Yeah, no, that's true. But one other aspect of it is that, so you can, as you saw from these examples for the Python tutorial, you can use the bioregistry to take any messy, non-standard usage of prefixes and identifiers and standardize it. And so it's possible to keep the original resource as is. We don't need to change it necessarily for it to become standard. We can sort of just use it as is and convert it into a standard, which is pragmatically kind of a better way to do this, because typically what happens is, if we were to go back to, let's say, one of the widely used ontologies and say, all of the ways in which you refer to MASH are non-standard and nobody else uses that prefix, they would say like, we might not want to change it because people are already relying on how it's written. They might have downstream code that looks at the specific way of formatting MASH IDs, for instance. And we don't want to change ours.
Actually, since you are doing this, we can actually see a lot of conflicts, right?
Yeah.
And then they should somehow get together, solve that, and then it will be good for the community, right? Otherwise, we see conflicts. Right? We actually look at the MASH, Mondo, disease ontology, whatever, OMIC, right? And then we try to use the most comprehensive one and then add information from other, but they have conflicts. We don't know which one we use. And then, because we're not experts, but then, so it's a big.
This is solved more by this mapping workflow that we've worked on. The bioregistry supports building up a good mapping set. But definitely this is an unsolved problem.
I think I mentioned in some of the BDF meetings, this SEMRA project that also Charlie and I have been working on, and that's more at this level of mappings, for instance, across disease resources. And then it's a way to expose the current state of mappings across these resources systematically and using a data structure that allows you to make inferences. So to say that
Yeah.
A maps to B, B maps to C, and therefore A is also equivalent to C, something like that, right? And we're about to preprint that, and I think that might be, like, for instance, if you're looking at integrating across disease resources, that might actually be a good starting point for that conversation of like, okay, this is the best you can currently get automatically in terms of mappings across these resources. Let's use this as a starting point to complete missing mappings or finding consistencies and so on, right?
So some of these problems are one step even further than mapping because of the different ways that ontologies are. Well, here's a good example is in the disease ontologies. They can't really decide what's the ontological basis for what's a disease. And I already said last night, you want to start a fight at this conference, start talking about like, hey, what's a disease? Is it a quality or is it a process, right? And so depending on your use case, this may have huge implications. If you're doing ontology-based reasoning, this is a big deal. But the mappings, they have a certain level of granularity. And also the other thing to keep in mind for SEMRA is that this is configurable. So you can say, here's my prior knowledge and here's my perspective. And that can become part of the mapping workflow to make a consistent output that matches your expectations. Because these aren't problems, if these are problems that could really be generally solved, then the community's here. Lynn is down the hall, Nicole is down the hall, they would just solve the problem together if it were possible to do it in a general way. But there's benefits to having these different perspectives, and that's why there are these conflicts in the community, and or not conflicts, parallel tracks to modeling similar things, the same things.
Yeah, all right, great, yeah, well, thank you, yeah, nice work.
Will you be around for the rest
Yeah,
of
yeah,
the conference?
yeah,
Okay, we should talk more about that.
Yeah,
I think
that's
we'll
okay, yeah, well,
introduce
first time, yeah, talk more. Yeah, okay.
Nice to finally meet you in person. So what's on the schedule next? Is it a break now?
We have
or
break, and this room is hackathon all day, which is just space for whoever wants to use it for whatever. And in parallel, there is the global biodata and like AI curation sort of.
Yeah, I'm going
all
to
that.
the other room.
I think that's gonna be pretty well attended.
Yeah, stuff, yeah.
Like, we'll hang out in here and just see.
I have a query.
Yeah.
So, have you thought about
So Ben used a very simple set of tools to solve these problems, and my answer to this is if you don't need to use these big complicated AI solutions, then don't. And a lot of what we're doing now is possible to solve with like a very small set of curation tools. So
I mean, I would, but I think it could still be a good idea in principle, right? So if you, in an ideal world, you would be like, here's a paper describing a new prefix, create the pull request for me automatically, right? And I think conceptually, I think that would be a good idea, but I think it would be quite complicated because the paper is usually not enough. You would have to go out to the website, you would have to navigate the website, figure out different things on the website, kind of have Charlie clicked around the website. And then it's like translating that to the bioregistry schema and all that. It could end up being quite a big engineering challenge, but it's a cool idea, right? I mean, it's like, we've thought about it.
one of the questions that's still open is, like when have we done enough bioregistry? There's gotta be some kind of equilibrium at some point where we've covered most of what's useful for the biomedical community, and then there's like a small stream of useful things that are still published. And yeah, what we haven't done is we haven't made a systematic assessment of like what's the remaining effort that could be done. That's something that maybe as the text mining workflow matures a little bit and there's more time training, we may be able to go for the last 15 years of on every single paper and make some kind of estimate like what could possible curation be. But the stuff that is useful that comes up in like the biomedical use cases, we find these papers and actually want to integrate this into a resource and then we add it to bioregistry.
Yeah, well, the other thing is that I think what is the space of things that we haven't come across yet and therefore registered in the bioregistry? Would be things that nobody else has ever registered because we're already drawing on all these external registries. It would be things that nobody has ever used as a cross-reference in another resource.
就刚才上次那个，昨天那个 classroom
Right, so it would be to have to be a resource that's kind of obscure because nobody else has registered it, nobody else has referred to those identifiers in a systematic way, right? And we do find those periodically, right? But they are typically gonna be like kind of less central to the community than what is already there, right? Then again, all the new publications do, of course, mention resources that are just completely new and therefore haven't been registered even though they are notable. Yeah.
Centralized system so that everyone or an individual can access to all the data.
But where, again, the bioregistry doesn't have the data from the other resources. It just tells you where the data is. And actually, it even has a further caveat that a lot of resources don't make it easy to get the data. Ontologies are a good example where they are pretty progressive and you can download the ontology artifact. But for example, the one that we just did a new prefix request on, it's not obvious how you can get the data about each of the resources. It only tells you about the resource that exists, the kinds of things inside it, and how to look at the web pages about them. I did a little bit of snooping, and it is possible to download either sort of proprietary mass spec files that are about each of the entities inside this database we did, or there's like an output Excel sheet, which is sort of incomplete. So it's not so easy to go from this to we have all the data from all the resources. This is a non-trivial next step as well. But it's the first step, knowing what the resources are, what they're about, and at least their homepage is always the first step. And find the next part.
Overall, very nice work.
Thank you.
Then, yeah, we could try to register all the resources that you mentioned.
Yeah, let's do that during the hackathon. So I think we can grab some snacks, and then I need to email everybody who's in this hackathon track the Zoom link because I forgot to do that.
No one told me.
So I should probably go to the AI chat, but actually a couple of requests that came in during the
New prefix requests?
like update, and sure, complex part. So,
nice.
Okay, so I'll be on Slack. I'm still running the. I actually had to fix a couple more issues with the SEMRA build. One of them was Zenodo API key. Another one was I had to check out on biomappings the fix to the OBI IDs.
Oh,
that's on a branch.
I haven't fixed the whole biomapping.
And then now it's running again. So now it's up to Wikidata. So it's actually
Okay, good.
So I'll let you know how it goes. They'll be in the other room.
Right.
Maybe the fund for the database, yes, and then the journals say, oh, you pay to publish, they say pay to curate. It's like, so I was talking to some of the journal editors, because the NIH doesn't want to pay such high publishing. At the same time, they don't want to fund, well, it's still Trump's administration, they don't want to fund as many of the database or as much of the database cost. It's like, well, where's the money being come from? So I was talking to some publishers, and then we were just like floating some different ideas. It's like, well, what happens if when you publish your paper, you say, check, I want to publish it open access, check another box, I want my data curated, because the publishing house is already